Hello everyone and welcome back to this next lecture. So in this lecture, I'm going to show you how you can test your Curiosity Nano kit with the Getting Started project, which we downloaded a couple of lectures before. So I hope you have also downloaded the Getting Started project from the Curiosity Nano page on the Microchip website, and you know where it is on your computer. And it's important that you know the exact location where you downloaded it, because we will be opening the project through our MPLAB XIDE. So the first thing I'm going to do is I'm going to go and open the MPLAB XIDE, which is right here. So when you install MPLAB XIDE, it will provide this desktop icon, and that is the most convenient way to launch it. So this is the start page of MPLAB XIDE. Now of course, whenever you're watching this video, your start page may look a little different, for the simple reason that the software always changes, and therefore there may be configuration changes, which is why there may be a totally different start page or something very different. Again, the start page merely shows some helpful links, and there is the MPLAB X store where you can buy their latest products. I'm going to close this because we are not looking to buy anything. And then next to it there is a kit window. The kit window will show whichever kit we've connected. Now I'm going to bring the microcontroller into the video. So you can now see the microcontroller kit in the center of the video. So I'm going to zoom in a little. So I have already soldered the header pins to both sides of the PCB. So as I said, this is basically an 18-pin connector which I have soldered to the bottom of the PCB. So for example, if you come over here, you will see that I have soldered it at the bottom of the pads, actually by reversing, by flipping it over and soldering at the bottom, because we will be making connections on top, and therefore it's always better to solder at the bottom of the PCB. Now I am using a USB cable to connect my kit. I'm just going to zoom out a little. I'm using a USB kit, or rather USB cable, to connect my evaluation kit to the host computer. Now the side on the evaluation kit uses a micro USB connector, and on the host computer you can use anything which goes to your host computer. This is a typical USB-C type, but you can use anything that is compatible with your host computer. The only thing that you must keep in mind is that this USB cable must be a data cable. Now at the time of buying this product, as far as I remember, there is no USB cable included. This USB cable can be any cable which is a micro USB for the microcontroller kit, but it should be a data cable. That means you can use even a mobile phone USB cable, and for that matter, this USB cable was something which I used for one of my previous mobiles, but this was a data cable. If you use a mere charging cable, you will not be able to connect to your microcontroller. You will only be able to power it on. So therefore, make sure you use a data cable and not just a USB charging cable. So with this, I'm going to connect the other end to my host computer. So I'm going to stop the microcontroller video and go back to my MPLAB XIDE. And if I come back to the MPLAB XIDE, you will see now that in the kit window it shows our Nano kit, which is being as a connected kit. Right now, there are a few issues that you should remember. To begin with, sometimes this may not show up. As an example, supposing I disconnect my kit, and I'm currently disconnecting the kit. If I disconnect the kit, you will see this red cross, which means that this usually happens when a kit was connected, but it was later disconnected, right? So I'm going to connect it back, and you will see that it detects it again. This is something that you should see on your host computer as well, right? I hope you are able to get exactly the same results. Now, for various reasons, it is quite possible that you might lose connectivity altogether. So therefore, for some reason, like you're working on the microcontroller kit, and then suddenly you see that your connection is lost and this is completely blank. And that does happen, and sometimes it has happened with me as well. That could happen for various reasons, because remember, the USB connection is simply a serial connection, and this can be dropped for various reasons, either by the host computer or sometimes even by a microcontroller. So if for some reason this is completely blank, it merely means that the serial communication was broken. Close down your MPLAB XID, reconnect your microcontroller kit, and then open your MPLAB XID again. That's all you have to do, right? So if you look, there are a few links which are available with this, and you are of course welcome to watch these. Also at the same time, this will also give you the MPLAB demo examples and also the GitHub page, the same GitHub page which I showed you before. So what I'm going to do now is I'm going to open the project of the getting started, or rather I'm going to open the getting started project which we downloaded before. So the first thing is we will bring in the project window, and I'm going to go to window and click on projects, and that brings in the project window. Right. So in this project window, I'm going to go and open the project. So let me go over to my PC, users, know whichever place you have it. In my case, I have it in downloads, and in downloads there is the PIC32 getting started. So in the PIC32 getting started, if you click on this little plus icon here, you will see that you will expand. So now you can't open this directly, right? Keep going, look at the firmware. Within this there will be these three directories: firmware, hex, and images. Click on firmware, and then you will see this particular icon here. This icon is a chip icon, and this is the project file that you can open. So if you click on it, it will show you the project name, and you can open this project. And now you see the project has been opened. So in this we can actually browse through, but for now what we are going to do is we are going to program this particular microcontroller. We program a microcontroller kit with this particular project. So for that there are two things which you can do. The first thing is we need to compile the project. So there are various ways to compile the project. You can look at any of these things. For example, you can look at production, and production has several options. For example, there is build project, there is clean and build project, and several others. Now, build project means we are compiling the code and producing an object file. This object file is what will be downloaded onto your microcontroller and can be executed by the microcontroller. Now, there are two options: build project and clean and build project. I always recommend using the clean and build project, because the clean will delete any existing compiled files and will completely rebuild the project. If sometimes there are any errors or issues, sometimes those issues remain on in the build directories, and eventually they end up correcting your final object file, or rather the final file, or rather the final assembly file which should be downloaded to your microcontroller. Whereas when you clean and build, it will clean the entire build directory and create it all over again. So let us click on clean and build, and here you see the output. So here, most important, let me just zoom up a little. You can look at the output. The output is basically compiling all the files. I'll go into these details a little later. It is compiling all these files, and it is giving us a final message which says that the build was successful, right? So it is now loading on this particular code, has been put into this particular directory, which is a production hex file, and this shows that our compilation has been successful. Now the program is not yet running, and that is very important to remember. It is merely compiled the file. So if you are wondering that there is nothing happening on your microcontroller kit yet, it merely means that the program has not been downloaded yet. It has been merely compiled. So with this, I'm going to bring the microcontroller back into the video. So the microcontroller is back into the video, and it is in the same state it was when we first powered it on. The LED, the green LED is glowing. That is the one here, which just shows that it is receiving power from the host computer. Other than that, we see no changes. So to program the microcontroller, again there are several options. For example, we can go into what is called as the production, this option, and you see there are many here. For example, the simplest is the make and program device. There is a debug mode, there is a production mode, and there are many other modes. In this course, we'll be using mainly the make and program device option. This can also be found in this quick option here. For example, if you use this, you see the same options coming up here as well. You can use whichever you prefer. If you prefer icons, you can use this. If you prefer actual options, you can prefer this, or other text options, text menu options, you can prefer this, whichever is okay. So I'm going to go and click on this make and program device, and this will show you, will ask you in the very first time, it will ask you how you want to connect to it. And in our case, you see there is no tool, which is like, I don't know what it will do. The other is a simulator. So you can offline simulate the behavior of this code using a simulator in case you want to put breakpoints and you want to see the values of variables. However, in this case, we will use the third option, which is our actual curiosity Nano kit. So I'm going to choose this and I'm going to say OK. And you can see here, there is now a yellow LED which is flashing on the microcontroller kit. So I hope you got exactly the same result. This implies that our code is now successfully running, because as we saw in the description, it will flash this LED at 500 milliseconds at the very first step. You can of course also press this switch. So for example, if I press this switch, you will see that the time interval increases to 1 second. And if I press it again, the time interval increases to 2 seconds. And if I press it again, it will increase to 4 seconds. And finally, it goes back to its default 500 milliseconds. That is what this is. So this shows that our microcontroller kit is working correctly, and we are able to execute the getting started project successfully on our microcontroller kit. So I'm going to end the microcontroller video, and with this I'm also going to end this lecture, because the purpose of this lecture was to be able to open a project on MPLAB XIDE and to be able to run this project on a microcontroller kit and verify whether the kit is working correctly. In the next lecture, I'm going to give a short walkthrough about how we can arrange this MPLAB XIDE and how to understand the project files. So if you had any issues, such as you were not able to get this microcontroller to work, or you did not get a flashing LED, or you faced any other issue, please post in the Q&A forum and I'll be happy to help you out. Otherwise, I will see you in the next lecture. Thank you so much for listening, and goodbye for now.